Welcome back to our chapter on arithmetic progression or AP, and now we get to the most interesting part of the chapter, which is problem solving. So there are 6 different types of questions that you can be asked in this chapter on arithmetic progression. Is the sequence an AP? So you'll be given a sequence and you have to determine whether it is an arithmetic progression or not. Then to find the common difference D, to find the nth term of an AP, which is Tn, to find the number of terms in an AP, which is n, to find the sum of the first n terms of an AP, which is Sn, and finally to find the consecutive terms of an AP. So they might ask you find 3 consecutive terms or 4 consecutive terms. And if you remember in one of the previous videos, we determined how to name an AP with even terms and name an AP with an odd number of terms. So that's what you use to find consecutive terms of an AP. So we'll discuss how to solve these questions in pairs. So first we are going to discuss these 2 questions. We're going to find out how to determine if a sequence is an arithmetic progression, and we'll determine how to find the common difference D. So before we do that, we need to recap the definition of an AP. To determine whether a sequence is an AP, we first need to know what exactly an AP is. So let's recap. So an arithmetic progression is a sequence with the same difference between any 2 consecutive terms. So you take any 2 consecutive terms, you subtract them, and you should get the same difference every time. So that should give you a hint of how to determine whether a sequence is an arithmetic progression. You simply take pairs of consecutive terms like T1 and T2 or T2 and T3, T3 and T4 and so on, and you subtract them and you see whether you're always getting the same number. If you always get the same number, the sequence is an arithmetic progression. If you do not, then it is not an arithmetic progression. And if it is an arithmetic progression, then that constant difference will be your D, the common difference. So let's see how this would look symbolically in mathematical terms. So we know the nth term we've denoted by Tn, that's T suffix n. So what would the n plus 1th term, the next term, be? So the n plus 1th term, you would just substitute n plus 1. So it would be T suffix n plus 1, right? So now we know 2 consecutive terms of an AP. We know Tn is the nth term, and we know the next higher term is Tn plus 1. So the difference between these 2 consecutive terms we'd find by subtracting. So Tn plus 1 minus Tn would give us the difference between these 2 consecutive terms. And if this was an arithmetic progression, then the difference would be constant, and this common difference would be equal to D. So D is the common difference, and the suffix n that we've used belongs to the set of natural numbers. So n can be any natural number from 1, 2, 3, 4 onwards, anything. So this is how we express the definition of an arithmetic progression mathematically. You take 2 consecutive terms, Tn and Tn plus 1. You subtract Tn from Tn plus 1, and you should get a constant difference D, where D is called the common difference and n is any natural number. So let's move on and see some problems that we can solve. So you're given the sequence 1, 3, 5 and 9. Okay. So basically what you're told is the first 4 terms of the sequence. So let's put it in our mathematical notation. So T1 is equal to 1, T2 is equal to 3, T3 is equal to 5, and T4 is equal to 9. So how do you determine whether the sequence is an arithmetic progression? So like I said, you've got to take pairs of consecutive terms like T2 and T1, T3 and T2 and T4 and T3, and you subtract them and see what difference you get. So first we do T2 minus T1, that is equal to 3 minus 1, which gives us 2. Next we take T3 and T2. So we do T3 minus T2, which is equal to 5 minus 3, which is again equal to 2. Finally we do T4 minus T3. This time that is 9 minus 5, which is equal to 4. So here we see that this term is not equal to the other 2 differences that we got. In the first two cases we got 2, but now we got 4 as the difference. So therefore T4 minus T3 is not equal to the difference, let's say T3 minus T2 or T2 minus T1. And because these differences are not equal, you say here the difference between two consecutive terms is not constant, right? Hence, the given sequence is not an arithmetic progression, is not an AP. So that's simple enough. You're given a sequence, you take pairs of consecutive terms, you subtract, and you see if the differences are constant. If they are constant, then what would you do? You would simply change the last two sentences by cancelling out the nots. So you would say here the difference between two consecutive terms is constant. Hence the given sequence is an AP, right? So if the given sequence is an AP, you simply omit the nots in the last two statements. Everything else is the same. You find the differences between consecutive terms, you find that they're all the same, and you say, yes, here the difference between two consecutive terms is constant, hence the given sequence is an AP.